How could a rotary engine, famous for choking on its own fuel, be making a comeback in the electric age? I'm Morgan Lane, and this is Recall Roadmap with Morgan. I've spent years testing cars and chasing down safety and reliability stories, and this one grabbed me. I dug into University of Michigan and EPA archives from the 1970s, and the numbers were brutal. In a 1976 study, a Mazda Rotary burned about 20% more fuel at around 35 mph than a comparable 3.8-liter V6. Worse, hydrocarbon emissions came in 6 to 10 times higher. That's not a tiny miss. That's a canyon. Regulators saw those figures and said, nope. Owners felt it at the pump too, so the Rotary faded out. And yet, here we are. Engineers are bringing it back. Not to spin the wheels, but to quietly run as a small generator for batteries. The pitch is simple. Keep it at one steady speed, hide it behind modern emissions tech, and use its compact, smooth nature to your advantage. Will that finally solve what killed it? What do you already know about rotary engines? I want to hear your take. Let's start with the basics so the comeback story makes sense. Picture this. No pistons, no valves. Just a triangle-shaped rotor spinning in a funky oval housing. That's the Wankel Rotary. Each corner of the rotor, an apex seal, slides along the housing and creates 3 moving combustion chambers. As the rotor turns, those chambers suck in air and fuel, compress, fire, and push, over and over in a smooth wave. Fewer moving parts than a piston engine, and power feels like one long pull. That's why engineers loved it. High revs, compact size. Great power to weight. Mazda built its RX sports cars around it because of its compactness, smoothness, and high RPM capability. An industry write-up in 2018 summed it up just like that. In simple terms, you could get the punch of a bigger engine from a small, light package. A classic 1.3-liter 13B could make roughly 160 horsepower decades ago. Eye-opening for the time. And the feel? Butter-smooth revs that begged for more. But here's the catch. That elegant motion relies on those little apex seals riding a hot, oddly shaped wall. Keep that picture in your mind, because the same design that made it sing also set it up to struggle. Next, let's see when the shine started to wear off. If the Rotary was so clever, what went wrong after the early thrill? The history is a wave. NSU took the first big leap in the 1960s, and Mazda pushed it worldwide with the Cosmo in 1967 and the RX-7 in 1978. Through the 70s, 80s, and 90s, those cars built a legend. Compact engine up front, light nose, silky power band. Drivers loved it. Then the world changed. Oil shocks hit. Clean air laws tightened in the US and Europe. Engineers tried to tune the Rotary lean and clean, but the engine ran best with a richer mixture to help cool and lubricate. It also misted a bit of oil into the intake to protect the seals. That mix, more fuel and some oil, was the seed of the problem. Early lab tests started showing gaps you couldn't ignore. I tracked down a 1976 EPA comparison that pitted a Mazda 13B Rotary car against a typical 3.8-liter V6. It didn't go well for the Wankel. We'll open those numbers in a second. But imagine being an engineer then. The car that felt brilliant on the road was failing on paper. How bad was it? Let's pop the lid on the lab book. I pulled the old test data so we could see it straight, not as folklore. At a steady 35 mph, the Rotary burned about 20% more fuel than the 3.8-liter V6 it was matched against. That alone was hard to swallow during a fuel crisis. But the emissions were the showstopper. Hydrocarbons, basically unburned fuel, came out 6 to 10 times higher from the Rotary in those tests. Carbon monoxide was also significantly greater. Nitrogen oxides were lower, but that didn't save the scorecard. Even after tuning the spark and mixture to the Rotary's sweet spot, hydrocarbons still landed around 3 to 5 times higher than the piston engine. So regulators saw an engine that used more fuel in key conditions and left a lot of raw fuel in the tailpipe. To be clear, the test cars were typical for the mid-70s. a Mazda RX with a 13B and a Detroit-style 3.8 V6. But the gap was too big to chalk up to old carbs alone. The next question writes itself. Where did all that unburned fuel come from? The answer sits at the corners of that spinning triangle. Time to meet the apex seal. One tiny part carried the whole dream. The apex seal. Each rotor tip needs to stay airtight as it slides along a curved wall that heats unevenly. In practice, that seal is fighting hot spots, cool spots, and combustion blasts every turn. The EPA analysis called out leakage of mixture past the engine apex seals as the most important factor behind the rotary's high hydrocarbons, along with incomplete flame burn in some areas. In plain English, a little air fuel slipped by before it could fully burn. To keep those seals alive, Mazda fed a bit of oil into the intake. That oil helped lubricate and cool, but it also meant the engine burned oil by design. If you ever saw a bluish puff from an old RX, that's the reason. Owner reports from back in the day often mentioned topping up about a pint of oil every few hundred miles. It wasn't a defect, it was part of the system. Put it together and you get the loop. Leakage wastes fuel, oil adds smoke, and efficiency drops. It's not laziness, it's geometry and heat. So if these limits are baked in, can modern tech work around them? Let's see what Mazda did next. By 2011, the music stopped. Mazda built a legacy on the Rotary, but the RX-8 was the last one to roll off the line. The company was clear about why. Fuel efficiency and emissions concerns made the Rotary a bad fit for modern rules and buyer expectations. The engine still had fans, but regulators and market math had the final say. This wasn't a surrender on innovation. It was a pivot. Mazda pointed its R&D toward electrification and efficiency, laying out a plan to have about 95% of its lineup electrified by 2030. That meant hybrids, plug-ins, and pure EVs, and a fresh look at old ideas with new jobs. And that's where the surprise enters. In 2018, Mazda confirmed a twist. It would build two EVs, one pure battery car and one with a tiny onboard gasoline generator. The generator? A Wankel Rotary. The same engine that struggled as a prime mover might live again as a helper. Sounds wild, right? But the logic is neat. Keep the engine small, run it at one calm speed, and let it feed a battery instead of the wheels. Next, let's talk about why that could work in an EV world. Here's the twist that gives the Rotary a second life. In a range extender EV, a small engine doesn't drive the wheels. It runs a generator at a steady speed to charge the battery when needed. That steady state is where the Rotary's compact size and smooth spin shine. Mazda said in 2018 it would launch two EV paths, one all-electric and one EV with a Rotary generator on board to ease range anxiety. Remember the BMW i3's little motorcycle engine? Similar idea, different tool. Mazda wants its own tiny Wankel for the job. Running at one optimized RPM means hotter, stable exhaust, and emissions equipment that stays in its happy zone. The engine can switch off when not needed and wake only to top up charge. That cuts the idling and stop-go waste that crushed the Rotary's reputation. You're watching Recall Roadmap with Morgan. If this breakdown helps you think smarter about future powertrains, hit subscribe so you don't miss what's next. Because next we'll get specific. What has Mazda actually built and tested, and who else is betting on this plan? Let's open the prototype folder. So how would a modern Rotary range extender work in the real world? Mazda hasn't kept this secret. Years ago, it tested a Mazda 2 EV with a tiny 330 CSCC single rotor, making about 26 horsepower. That's scooter-sized power, but remember the job. Just keep the battery from dipping too low. Patent filings point to smart start-stop logic so the engine shuts down cleanly and avoids the flooding issues that once frustrated owners. Keep it simple, keep it steady, keep it clean. Partnerships matter here too. Mazda's North America chief noted that Toyota's e-Pallet shuttle program could use Mazda's Rotary range extender know-how. That's not nostalgia. That's a practical supply of a compact generator module to a big partner. It's also a hint that this tech is being treated as a building block. Drop-in, predictable, and tuned for one task. The theme is clear: shrink the engine, box in its operating window, and let software do the heavy lifting. But clever packaging isn't the same as curing old wounds. Can new materials, injection strategies, and fuels really tame leaks and unburned fuel? Let's judge the fixes with fresh eyes. Can the Rotary's weak spots be tamed in 2025? Some tools look promising. Direct fuel injection can aim the spray away from hot walls and late in the cycle, cutting the puddling that feeds hydrocarbons. Advanced engine control can run very lean at a single sweet RPM. Start-stop logic prevents waste and reduces the old flooding risk. Better coatings and seal materials handle heat and wear more gracefully than what engineers had in the 70s. Mazda has also talked about running cleaner fuels like LPG in a range extender setting, which can help the catalyst keep emissions down. There's outside innovation too. Companies experimenting with rotary variants like liquid piston chase similar goals: compact power with better sealing and burn. In labs, even hydrogen-assisted ignition has been explored to improve flame start. But let's stay honest. As we saw in the EPA study, the Rotary's big enemy was unburned fuel from sealing and combustion quirks. Running at one steady RPM and through strong aftertreatment hides the worst of it, but it won't turn a Rotary into the most efficient generator on Earth. It's an incremental fix matched to a narrow job. So, for a buyer, how does that trade feel day to day? Well, here's the real-world picture. Mazda's first production try at this concept, the MX-30 with a rotary range extender, reached some markets around 2023. In a setup like that, you drive on battery most of the time. When the charge drops, the small rotary wakes, spins at one calm speed, and feeds the pack. City trips might never use it. Highway trips will. Expect smooth operation, likely a gentle hum, and a useful safety net for range. But remember the trade. A rotary generator is compact and quiet, not magic. When it runs, fuel economy may be modest compared to a similar small piston generator. Maintenance should be simple. One small engine turning a generator at steady load, but the design still uses apex seals and a dose of oil for lubrication. Plan for routine checks and stay current on software updates that manage start-stop and emissions. Also note, EV labels treat range extender cars differently with separate electric range and gasoline ratings. If you value quiet miles and a backup for road trips, this could fit. If your goal is the best miles per gallon when burning fuel, a piston-based hybrid may still win. Either way, early reviews will matter. So what did we learn? The Wankel Rotary didn't fade because people stopped liking it. It faded because the numbers didn't line up. That 1976 study showed about 20% worse fuel use in key conditions and hydrocarbon emissions many times higher than a piston rival. Apex seal leakage and oil burning were central to that story. Today, the Rotary's comeback is nush and smart. Act as a tiny generator at one steady speed, keep emissions gear hot, and give EVs a quiet, compact range backup. Mazda even claims this setup can help eliminate range anxiety, while its broader plan targets about 95% of its lineup electrified by 2030. I'm cautiously optimistic. As a safety and reliability guy, I like the honesty of a narrow job matched to a known strength. But I also respect physics. This won't be a fuel-sipping miracle. Watch the road tests, check the maintenance schedule, and judge by the data. Thanks for watching. If you found value here, hit subscribe, like, and share to help others make smarter choices. Final question. Do you welcome the Rotary's return as a range extender, or do you think it's still a dead end? I'll see you in the comments, and I'll see you in the next deep dive.